Today I'm going to give you an introduction to factoring. So let's go ahead and get started. So if I were to ask you to multiply 3 times 4, what would you call the 12? Well, of course, that's the product. But what about the 3 and the 4? Well, we call these factors. Now I could ask this question in a little different way. What if I asked you to factor 12? Well, 3 times 4 certainly works, but notice we have a couple other pair of factors that work, 1 times 12 and 2 times 6. In fact, we have 3 different ways to factor here. So one of the things I want to point out at this point is that multiplication and factoring are actually opposites. And so whenever we do factoring, we're going to be using multiplication to check ourselves. Let's move on to the next slide. So if I ask you to factor 8x plus 16, could you come up with 2 expressions that you can multiply together to get 8x plus 16? Well, 2 times the quantity 4x plus 8 works. And how about 4 times the quantity 2x plus 4? And there should be one more. 8 times the quantity x plus 2. Now the problem here is we mathematicians don't really like getting 3 different answers when we ask you to do something. In fact, we're going to limit ourselves to just the last answer here, 8 times x plus 2, and we're going to change our directions to factor out the GCF. In fact, if you look at 8x and 16, the largest number that you can factor out of each of those is 8. Or the other way to say it is the largest number I can divide 8 and 16 by is 8. And so we're going to factor out the GCF, and that's what we're going to use to factor problems like this. I also want to make the comment here just what factoring is. Factoring means to write out as a product. So notice what we started with, the 8x plus 16, we had 2 terms added, and in our final answer we have a product, 8 times the quantity x plus 2. So to factor means to write as a product. Let's move on to the next slide. So the directions here to factor out the GCF, and so we've got 9x minus 12. So first of all, for 9 and 12, the largest number we can divide each of those by is 3. Whoops, let's change that. So we can factor out a 3. Now basically, we're doing the distributive property backwards here. So 3 times something is 9x, that would be 3x. And 3 times something is negative 12, that would be a minus 4. Now notice we can check this by distributing. Remember, if we multiply, we should get back what we started with. And sure enough, 3 times 3x is 9x, and 3 times a minus 4 is 12. Another way to get the 3x minus 4 is to actually divide each of your terms by the GCF of 3. Notice 9x divided by 3 gives you the 3x, and 12 divided by 3 gives you the 4. Let's move on to the next problem. Alright, so here the first expression has 3 factors of x, and the second term has 2 factors of x. I'm sorry, 1 factor of x, and so we have 1 factor of x in common. And so it's going to be x times, now again, since we have 2 terms here, we're going to have 2 terms inside the parentheses, and x times the first term should be x cubed, so we need an x squared. And x times the second term should be x. Well, x times 1 is x, and we're going to need a plus here. Again, you could check this by distributing x times x squared gives you x cubed, and x times 1 is x, and so that's how we check ourselves. The other thing you'll notice is inside here you have no common factors, which is an indication that you factored out the greatest common factor. Let's move on to the next problem. So here, notice we have a greatest common factor for 3 and 12, that would be 3. And then the first term here has 2 factors of a, the second one has 1. So they both have at least one factor of a. So our GCF is 3a. And so we're going to have to figure out 3a times something is 3a squared. We need an a. And 3a times something is 12a. That would be 4. So let's move on to the next problem. So you should stop the video and give this a try, and then you can check the answer against what I get. Let's go ahead and do this. So for 4, 6, and 2, the GCF is going to be 2, and the smallest power of x would be x. So in other words, each of these has a factor of x. The first term has 5 factors of x, the second term has 3, and the last term has 1. They all have at least one in common. This time we're going to have 3 terms inside the parentheses, since we have 3 terms to start with, and 2x times the first term should be 4x to the 5th power. Again, I can divide each of these by 2x to figure out what goes inside the parentheses here. Notice 4x to the 5th over 2x, we're going to get 2x to the 4th. Remember, this is a 1, so 5 minus 1, we're going to get x to the 4th there, plus 3, and we got 3 minus 1, we're going to have 3x squared, and then finally 2x divided by 2x. Here we're going to get a minus 1. Again, if we distribute 2x times each of these 3 terms, we do get what we started with. And so you can verify your answer that way. The other thing you can look at is each of these terms, if you look at them, there's no common factor, which tells you that you did factor out the GCF. Let's move on to the next page. So again, you might want to stop the video and do this problem. I'm going to go ahead and do it now. Greatest common factor here. Now notice there's only a common factor of 3. There is no common factor of a because the last term here doesn't have a factor of a. So 3 is the only thing we can factor out. It's going to be 3 times a squared minus 3a plus 2. And let's move on to the next problem. Whoops. There we go. Alright, so go ahead and try this one here, and then you can see how I did it. So for 24 and 16, the largest number you can divide both of those by would be 8. If you look at the x's, the smallest power, they both have an x as a factor, but the smallest power of x is x to the first. And if you look at the y's, we have a y to the 4th and y squared, so the smallest power of y is y squared. Again, we're going to have 2 terms inside since we have 2 terms to start with. And 8xy squared times something is 24x to the 6th, y to the 4th. Well, 8 times 3 would give you the 24. X times x to the 5th would give you x to the 6th. And y squared times y squared gives you y to the 4th. And then you're going to have minus 8 times 2 is 16. And in fact, we already have an x and a y squared, so that is going to be our final answer. Let's do one last problem here. Notice it's going to be a little bit different. Now when you look at this, you gotta be careful to sort things out correctly. Notice we really have two terms here, just like we did in the one that we just did before, number 6. But in this one it's a little bit different. We don't just have a single number or term that's a factor. In fact, in this case we have x plus 2 as our common factor. Notice in the first term here you have x plus 2 times x. In the second term you have x plus 2 times 3. So x plus 2 is your common factor, and since we have two terms, we're going to have two terms in our parentheses here, and x plus 2 times this first term should equal x times x plus 2, our first term over here. Well, we're missing the x times x plus 2, that's our first term. And then x plus 2 times this second term here should equal what we have here. So we have x plus 2 times 3, so we're going to need, to put in a plus 3 here. And so our final answer is the quantity x plus 2 times the quantity x plus 3. One thing I would point out here, let me try something a little different, is if we were to cover the x plus 2's, you can see the x plus 3 that's left over, and that's what goes in the other parentheses. So that's a little shortcut for doing those. Anyway, that's the end of this lesson. Have a great day.